to our second ed puzzle for looking at coding in CSP. We're going to talk a little bit today about conditionals. Last time we did an ed puzzle, we talked about variables, and we introduced two variables. We introduced this yellow sticky note for numbers and this pink sticky note for strings or words or phrases. Today we're going to introduce a blue one, and that's going to be for this idea of Booleans. So let's look back. Here we are with our yellow sticky notes. We got some ideas here. It could be any kind of number. A string can be any kind of word or expression, even if it includes a number, like the idea of see you late, or as long as it includes a character in it, then it gets classified in JavaScript as a string. So now we're going to introduce this idea of a Boolean, spelled just like it looks, bool, and then lean, and it can be evaluated to just true or false. So think about true or false in this. And how we use it is just to look at any kind of expression or comparative, and then have the computer decide if that's true or false. In this case, we use the example of 3, and then we have this operator less than 8. So just to make sure you're awake, tell me, is 3 less than 8? Is that true or false? Hopefully you picked true. That's how I'll know you're awake. Good job if you got that right. And let's just kind of look at this idea then. Since 3 is less than 8, that would evaluate to true. And we can use the less than operator. But if we wanted to, we can use some other ones too. We can use greater than. We can use less than or equal to, greater than or equal to, and then notice that the equal to is the double equal, because if we use a single in computer language, that's like you're assigning something. So we have to use a double equal to tell it, no, just evaluate that. And we've introduced this other one where there's this exclamation point and then an equal to. That means not equal to. That's their way of showing not equal to. So let's look at another example. In this example, we've got two variables being added together, 3 plus 6, and then it says, is that less than 8? Before the computer decides if that's true or false, it goes ahead and evaluates. It says, oh, 3 plus 6 is 9, and then is 9 less than 8? You tell me, is that a true or false statement? Hopefully you said false. None of these questions are super hard this morning, right? Let's keep moving and try some on here. Let's see. I'm going to have you try the third one down. So in this example, it evaluates each side. Okay, so we do 6 minus 3 is 3. 4 plus 1 is 5. Is 3 less than 5? Yep, that's true. Then we go to the next one and we say 12 divided by 6 is 2. 3 minus 0 is 3. Is 2 greater than 3? Nope, that's false. Now it's your turn. Look at this next expression and tell me, is that going to evaluate to true or false? Hopefully you said false, because 12 is not less than or equal to 10. If you did that, you got it right. Let's look at the last one together. We get 9 plus 5 is 14, and 4 plus 10 is 14. Are those two equal to each other? That's what that double equal sign means. Yes, that's true. Now that we have that idea, let's see how we might apply that if we were doing some computer coding. So in this case, we have to think back to the Ziploc bags that we use. That's how we store these kinds of information in this variable, like that Ziploc bag variable. So if we stored the information lives and we gave it the value 5, and we stored the information score, like we had a game where you had lives and score, and maybe in there we stored a 10, and then we could just see, oh, is this true or false? So in this example, we replace lives with 5, because 5 is what's stored in there. We get 5 plus 4. And we replace score with 10, and we get 10 minus 1. Is 9 less than 9? We should say false on that. And so we can use that idea if we're doing some game coding and we want to decide if we're still going to continue the game or if we're going to end our game. Notice that the expression for true or false, that's the way these Booleans get evaluated. Okay, Let's do another one together, and then I'm going to have you guys try one. So here's the idea of, can I go to the movies? I'm allowed to go if it's before 8 o'clock. That's the idea. Now let's figure out how a computer would code that to figure out if that would be true or false. So what information do you need to know? That's what you're going to create your variable for. And then you got to figure out what information you're given. That's what's going to go on your sticky. And then you can do a comparator, like a greater than or equal to, or less than or equal to decide if it's true or false. This is what we call a decision tree. You can see we created a variable, let's call it time, because that's what we're looking at. And we know now if time is less than 8, and that evaluates to true, we're allowed to go to the movies. If that evaluates to false, sorry, can't go to the movies. So then let's say, oh, it's 9 o'clock. If I put that time 9 in there, is this going to evaluate out this decision tree to true or false? You tell me. Let's see what you said. I put 9 in. I move that down in place of my comparator. There it goes. Is 9 less than 8? Nope, that's false. It should respond with, I can't go to the movies. Okay, now let's try another one. Back to our game idea. Have I won a game? I've won my game if score times my lives is greater than 10. In this case, what information do you have to know? You should say 2 things, score and my lives. So you might need 2 variables, two bags, and then they should have 2 sticky notes that are in there. Let's create a decision tree for this. Here it is. And let's see what happens when we have these tests. I'm going to ask you just to do the first test and tell me if your score is 3 and lives is 3, have you won the game or not won the game? You decide. You should have said that you won the game, or that you have not won the game yet. I'm sorry, because 3 times 3 is 9, and 9 is less than 10, so that evaluates to false. You've not won the game. Let's try another challenge. Is my dog older than me if his age is converted into human years? You may have heard that a dog's years are like 7 times that of a human. So what information do you need in this situation? Let's make another decision tree and see. We decide we need both ages, your age and your dog's age. And then we have to create this conditional that says, if you take your dog's age and times it by 7, and that's greater than your age, then it evaluates to true that your dog is older than you. If you take your dog's age times 7 and it's not, then of course that's false and you're older than your dog. So let's see. Another one. Can I adopt a cat? I can if I have $40 and I'm 14 years old. So in this case, what information do you know or need to know? And create a decision tree. Let's take a look. Here it is. You need to know how much money you have and how old you are. And then you have 2 conditionals in this case. You need to know if your age is greater than 14 and decide if that's true or false. And you have to have $40. Although I would argue if you had more than $40, you'd also be good. So let's try a scenario. Let's say you're 17 years old and you have $39. If I put those into my bags on my sticky notes, I can come down through here and say, oh, let's replace age with 17. Is 17 greater than 14? That evaluates to true. Then I go down here and try the next conditional that says, my money has to be 40. So I replace that with 39. 39 is not equal to 40. So that evaluates to false. And now I can't adopt a cat. So that's this idea of doing this kind of double conditional. And we're going to see how to make that a little simpler as we go through. So we're going to add in some logical operators that make that last example a little easier. We're going to add in an and, which is like this double and sign. That's at the shift F7. We're going to add in an or. That's these 2 lines. It's almost like the lines that you use when you do absolute value. That's just above the backslash, above the enter key on your keyboard. And then this idea of not, which is an exclamation point. And let's see how these then are used. So if something is true and false, it's going to evaluate to false. Let's take a look. We're going to add in another sticky note. We're going to make true's dark blue and false's light blue to make it easier to see what we're talking about. And we're going to do these truth tables. You might have done these in geometry, but if not, don't worry. They're pretty simple. So here's this idea that if something is true and true, well, then it better be true. But if anything is true and false, it's going to evaluate to false, because we always go with, in an and situation, false wins. So in this case, if you have two things that are true at the same time, will the expression evaluate to true? On the other hand, with or, if something is true or true, sure, that's going to be true. But if something is true or false, it's still going to evaluate to true, because we're going to use the or symbol. So the only time two things are false in this case is if they're both false. So when we use that or conditional, that means, hey, one or the other has to be true, but they both don't have to be true in order for it to evaluate as true. And if we use this not, it's really just like taking the opposite. It's almost like using a negative sign in math. So if you say not true, well, not true is false. If you say not false is true. So let's go back and do our CAT example one more time and think about using the and operator, because it says I can adopt a cat if I have $40 and I'm over 14 years old. And let's see how that simplifies our decision tree. So we still have two variables, money and age, but now look in the middle of our decision tree. Where the and is, it says if money is equal to 40 and age is greater than 14, I can go right down to true. And if either one of those is false, I can go right down and it's false. So now let's try it. Say I have $15, or I'm 15 years old and I have $40. You tell me, is that going to evaluate to true or false? All right, I hope you were paying attention. You should have said, oh, money is 40. Yep, age is 15. That's greater than 14. Both of those are true. So that evaluates to, according to our truth table, it's true. You can adopt a cat. All right, so let's do some key takeaways. We looked a little bit at this idea of a decision tree. We're not actually going to do this today in the Ed Puzzle, but you should see this in a Do Now or in some examples in code.org coming at you. How do you write this, and then how do you code that? You can see in here, so you start with your variables, you go to some kind of conditional statement. If it evaluates to true, you go to one answer. If it evaluates to false, you go to the opposite. And then we also kind of talked today about this new Boolean type, which evaluates to true or false, and how we can have comparison operators. That's your greater than, less than, greater than or equal to, less than or equal to, and then not equal to. You have to reduce each side of the expression before it can evaluate to true or false. And we talked about logical operators. And what did we learn about logical operators? Okay, now that you've answered that last question, you're good to go. You have just learned about conditionals and you're ready to try coding some stuff with conditionals. Good job, guys.